Hi everyone, welcome back to the Layer 3 curriculum. My name is Arul Richardson and I'm from the Technical Knowledge Management group, and I will be your lead instructor for this onboarding program. So in this video, I will talk about areas. Areas, to be more specific, OSPF areas. So let's begin. So I will explain the concept of areas taking help of this small network which is right behind me. So this is a small network with router number 1 until router number 10. Let's say that I have OSPF enabled on all of the elements in this network. Once OSPF is enabled, you know that OSPF shares the information of its own to its directly connected neighbors in the form of LSAs. So router number 1 will share its LSA to router number 2 and router number 3. In the same fashion, router number 4 will share with router number 2 and 7, and so on and so forth. And at one moment, what will happen is all of these routers will know about everybody. So at router number 1, this router will have information of router number 2, 3, 4, 5, 6, 7, 8, 9, and 10. Similarly, router number 2 and all of the other OSPF speaking routers in this network. So after all of these OSPF speaking routers will have their LSDBs same, they will attain full state. Now what is the problem? Now since this is 10 networks, you know that OSPF will calculate the best path using the SPF algorithm. Now this SPF algorithm runs over LSDB. Now we know that LSDB is nothing but a collection of LSAs. So router number 1 will have LSDB of all of the router information, that is the network information, router number 2, 3 and so on. Similarly, router number 2 and so on. So the thing is, the bigger the LSDB, the more time for the SPF algorithm to calculate the best path. It's very similar to the PDF file that you have in your day-to-day cases. So if you want to search something in your PDF file, and let's say your PDF file is of 10 pages, so the search is quick and instant. But the moment your PDF file becomes larger, let's say now you have a PDF file and that has around 1000 pages, and now you try to search something, so it takes time. The similar is with the OSPF areas as well. So SPF is quicker when it is a small network, but the moment the network is huge, meaning that now we have a bigger LSDB, the SPF calculation takes time. This calculation requires processing power. This calculation, if it takes time, will result into slower conversions, and this is a problem. Now again, keep in mind that OSPF is an old protocol. So in the early 1990s, 2000, there weren't so powerful equipments with the use of nanotechnology and powerful processors which can handle these cases. So at that moment, we need a solution, and the solution was areas. Areas used to divide the network into small clusters, and these clusters were called as areas. So now in this case, let me clear the stuff on the board and use another color. So now in this case, I will be breaking up the areas in this manner. So router number 1, router number 2, router number 4's upper interface and router number 3's upper interface, this belongs to one area. Let's say that this specific portion from here to here belongs to another area, and this portion of the network belongs to another area. Let's name this. Let's say that this is area number 1. Let's say that this is area number 2. And let's say that this one is area number 0. Now in OSPF, area number 0 is termed as the default area or the backbone area. So we have area number 0 always as the backbone area. there is some significance of backbone area. If area number 1 wants to talk to area number 2, then it cannot be direct, meaning that area number 1 cannot directly talk to area number 2. It has to talk via area number 0, and that is how OSPF has been designed. Now, having said that, let's see what is the advantage of this area. Now, the moment I have areas, what will happen is the routers in this area will only know about the network of its own area, and thus the SPF calculation will only run within this specific area. So router number 1 will have LSDB of router number 1, 2, 3 and 4. So it will have a view of this area or the routers in area number 0. Now, if you compare this LSDB with the LSDB which was available before area, obviously this LSDB is smaller. With smaller LSDB, the SPF calculation is faster, and also the processing of the router is less when calculating shortest path on a shorter LSDB. And that is one of the advantage of areas. Now, since we have areas, we have some terms that you need to know when it comes to area in OSPF. Over here, you can see that this router over here, router number 3, is a part of area number 0 and also is a part of area number 2. Now, just in case if you're wondering why I have missed router number 9, I will talk about it soon, don't worry. But again, going back, router number 3, you see that router number 3 is a part of area number 0 and area number 3. So such routers have view of both areas. So router number 3 has the entire network view of area number 0, and it also has the entire network view of area number 2. So usually these routers should have more processing capabilities than the routers which are there within the area. So usually such routers should be of high capacity and high processing power. These routers which connect a non-default area with a default area, or basically a router in OSPF which is a part of default and a non-default area, is termed as ABR, which is called area border router. So if you see over here in the same network, I have another router, router number 4, which is a part of area number 0 and area number 1. So this router is also termed as ABR, area border router. Now there is another term that you should know when it comes to OSPF and OSPF areas is ASBR. Let me use another color. Let's try to understand what is ASBR. Now you see this router number 9 which I had left long before. This is the reason why I left router number 9. Let's say that router number 9 has RIP as my routing protocol which is enabled on it. So if I want to redistribute all of my RIP routes into OSPF, okay, so RIP router, which is router number 9, is connected to router number 5. So even this interface will be a part of RIP routing protocol. So this router, which is router number 5, has both routing protocols, which is RIP and OSPF. This interface is a part of OSPF. This interface is a part of RIP routing protocol. So if I want to redistribute these routes of RIP into OSPF, so this router which is there, this router in OSPF is termed as ASBR, Autonomous System Border Router. So this is what you need to know. So like we discussed, one advantage of area is we have smaller LSDB, so there is quick SPF calculation. Another advantage of area is route summarization. In OSPF areas, you can summarize between two areas, meaning the ABRs can do summarization. So summarization can be done between area number 0 and area number 2. Summarization can be done between area number 0, area number 1 and vice versa. You cannot do summarization within the area, and you cannot have communication between area number 1 and area number 2 without passing through area number 0. And that's all that you need to know about areas in OSPF. There are different types of areas, but in order to understand different types of area, you need to first understand different types of LSAs. In the next video, I have explained all the types of LSA. So after that video, I will explain what are the types of areas. So I hope that you enjoyed this video, and I hope that this video was informative. I'll see you in the next part of the video where I will talk more and more about IP stuffs related to ECI. Until then, thank you.